Welcome to this session about Papyrus tool migration experiments. My name is Rémi Schneckenberger. I work at Eclipse Source in the French office. I am a committer of the project Eclipse Papyrus and also on several other projects hosted by the Eclipse Foundation. And I've been involved in the development of this tool, Papyrus, since its beginning more than 15 years ago. So let's jump a bit on Papyrus. What is this tool about? This is an open source UML2 modeling platform, which is based on Eclipse modeling framework and many other frameworks hosted by the Eclipse Foundation. It's based on modeling standards, UML, SysML, Foundational UML, ALF, OCL, and many others. And it's supported by an active open source community. And there are many domain-specific tools implemented on it, which are based on UML, SysML, and you can have a set of families of tools which are provided in this area there. Papyrus is not only a graphical and diagram modeling tool, but it also provides editors for based on tables and on form-based editions. It provides many other services than the diagram definitions and rendering. We have many other topics that are covered by the Papyrus tool, several of them being on the model management. That means serializing the files or the content of the models onto a database. There is a large UML support, and by this there is also some UML profile definition and usage support within the tool. There are some other frameworks like validation framework and editing frameworks for specific elements in the model. We can customize a lot of its views and lots of its actions that you can have in the tool. For example, we can have some customization about the palette definition. We can have customization about the modeling assistance. We can customize the property views, the content of the tree browser or the model explorer. And what will be the focus today will be about the rendering technology and the UI technology. Because these ones were based on old technologies, or I would say technologies that were 15 years old. For example, for the Papyrus diagrams, we rely on the Eclipse graphical modeling framework, which itself relies on SWT and Draw2D. Frameworks, which are 15, 20 years old. We also rely on the GF graphical editing framework, which is the free version. Since then, there has been the GF 5 version. We are relying also on SWT, which is the basic widget toolkit used by Eclipse IDE. And we also provide some CSS integration based on quite old version of the CSS language. As we mentioned already, it contains a lot of functionality, and it's hardly impossible and desirable to re-implement all of these functionalities. For example, a lot of the profile management and the customization management at the model editing level, we don't want to re-implement them from scratch because there was a lot of effort pushed into these functionalities. But while keeping all these functionalities, we would like to have a better UI and rendering technology, so we could have and benefit from the modern UIs and modern technologies for the diagramming frameworks. On the past experiments, we try to push some updates of the Jeffrey and the GMF runtime frameworks. Initially, we were based on Jeffrey and GMF, and we wanted to have some kind of proof of concept to go towards Jeff 5 implementation and also to be based on JavaFX for the graphics. The goal was to keep the same notation for the diagrams and reuse some part of the GMF tooling definition of the diagrams. while just updating the rendering and benefits from, for example, for the performances that JavaFX allows compared to Draw 2D and SWT. These experiments were conducted around 5 to 6 years ago, and they only stayed as a proof of concept because the effort to go towards J5 and JavaFX technologies were quite high, and it was, I would say, too much of an investment compared to the gains to migrate to these technologies. We would still be in the SWT frameworks from Eclipse, and we would need an integration of JavaFX canvas onto the SWT, which would mean also not so great performances improvements. We have seen some emergence of the web technologies over these last years since we did this experiment, over Jeff5 and JavaFX. On the IDE side, of course, we have this Theia new project, and we were also having some improvements over the modeling frameworks and also on the textual support from the IDE editors and the text editors, thanks to GLSP and LSP. So I will just do a quick focus about these web technologies and try to see how they can help with the modernization of the Papyrus tool and its migration towards these web technologies. A small focus on Eclipse Sphere. It has been presented quite a lot since it has been released, and it has been started since 4 years at the Eclipse Foundation. It's an IDE platform that allows you to develop both desktop or web-based IDEs, but sharing at the same code base. That means that you develop once an IDE and then you can just deploy it to other desktop or web-based application. Also the nice plus about Eclipse AI that it provides a flexible architecture, and you depends on or you applies modern architecture patterns onto the tools. That mean, for example, you are using dependency injections and modularization for your code. That means that you have a better modular architecture that you can either swap or customize on your needs, which would be a great plus for Papyrus derived tools. One great thing also is it's an Eclipse project, which means that it's an open source tool, and you can rely on vendor neutral tool development, which is great. And you know that you can just rely on these kind of technologies. And it has already been adopted by the industry. There are several tools or experiments or developments that have been done by the several companies. We have, for example, Ericsson, RRM, or Red Hat, and many other companies that have been already using this tool successfully. So we know that it's a quite stable and quite adopted platform, so we can go on it and push the developments on it. Another focus on some technologies which are brand new or not that old. That means Eclipse GLSP and Sproti. GLSP stands for Graphical Language Server Protocol. That allows you for development of web-based diagram editors, which would be the focus of this exercise for the Papyrus modernizations towards the web technologies. And the goal of GLSP and Sproti is to have SVG-based rendering. That means flexible and performance rendering for diagrams. And GLSP propose an architecture with this model client pattern. The client would be as generic and as light as possible, and hosted that can be hosted within Theia editor or any web browser. And the model server itself would contain all of the domain-specific language and can provide all the encapsulation that you need so that your client can just access the model and interact with it. GLSP is based on an extension, or it can be seen as an extension of the language server protocol, which was defined for textual editors, and it's the adaptation for the graphical editors, which is pretty good patterns also. Finally, I will just do a small focus on the EMF Cloud project. It's an umbrella for several other projects. Among these, you can find a model server, which is encapsulation of all the interaction that you can have with your model, and that allows you to be independent of the technology that you are using to serialize or to edit the model itself. May it be data-based or EMF-based models editing. It allows also you to edit the to manage the runtime state of the loading models, and you apply the changes to the model using the command pattern, and you rely on listeners to react to the changes. Among the other projects, you can also find the Theia tree editor, which is an implementation of a tree that can be easily integrated into the Theia. And it allows you to build data-centric editors as a tree form within Eclipse Theia. And you can also find two other editors examples that are based on GLSP. You can find the eCore GLSP editor, which is a basic implementation of the eCore meta model that comes from EMF using the GLSP editor. And you have also Coffee editor example, which demos some advanced functionality for the web-based technology, GLSP. You have some textual editing, other model, and many other features that you can have for model-based editor, graphical editor. You can find more details on this conference, on these technologies. I just provide you here a few talks that have been done this week about all the EMF Cloud and GLSP and Theia technologies. Many of them have already been done, so you will find them back again on the Eclipse, thanks to the Eclipse Foundation. Once we have conducted this experiment with Jeff 5 and JavaFX, we wanted also to conduct a bit more of experiments for the migration towards web technologies and modernization of the UI rendering. This time we did this experiment in collaboration with the Technology Universität of Wien. And we want to thank here Dominic Borg, that is working in the business informatics group. We work with 5 groups of 2 students, and the goal was to implement for each group one UML diagram editor using all these technologies. And we have picked up among all these the existing UML diagrams, the activities, the use case, state machines deployment, and the class diagram. For the configuration of this experiment, we did a 4-hour training on the technology stack, starting from EMF until the GLSP and the Theia and the model server stack. And the experiment was spread over 3 months, and each groups were working 1 to 2 days per week over this 3 months. We have already provided as an initial setup the following technology stack. All of them had Theia ID with GLSP, and Theia-based ID with GLSP, and its integration within Theia. And the model server was already configured with UML extension. That means that the UML meta model was already available, and they had some EMF UML editing domain and specific commands and the resource set that allows to manage UML models within the Eclipse environment and the EMF environment. And we also provided some commands that were extracted from Papyrus itself to allow addition of the elements. And finally, to not use the notation-based model, we provided a very similar EMF-based graphical definition, which contains mainly nodes, links, and what element is represented. The goal of the experiment for every group, the goal was to have front-end diagram rendering, to have all the operation on loss for the CRUD of nodes and edge for each diagram. For each of them, we only wanted some subset of the language because, for example, for the activity diagrams, there are many nodes that are possible to create, and we don't want to have all these nodes there. And we also had the implementation. We wanted to have the implementation of the UML commands on the model server, and we wanted to see how it conflicts between every editors that we can have for this experiment. And then once every group had these diagram editors available, we wanted to have them having further customizations in the direction of their choice. For example, some of them picked the integration of the validation framework, which is based on Eclipse UML rules. Some of them provided some custom edge rendering or some auto-completion and label validations for editing. So let's jump right now to the demos, and let's start with the class diagram example. As we can see here, we have a basic example which contains a student and a course and some of the properties. And I will just add there a property for using the palette element on the students. And as we can see here, the layout automatically adapts when we want to create a new property. We have a new compartment which contains all the properties. And I will just then add this new property. The nice thing, for example, here is we can see we have code completion. And the nice thing to notice there is the completion is not only about the types that you can find directly in the model, but also some types that are coming from eCore or from EML. And for these ones, the model server is has to be thanked there because it provides all the types that may be useful for a UML model. In this case, I will just select, of course, curriculum, which is the kind provided here, the type provided here. So as we can see here, the students provided a smart editor for the properties, which provides completion and also provides passing of the label there. Because, for example, if I just change the name of the enumeration, we can see that the property will also, the labels there will react because it knows that the type is this enumeration. So it's not only a string, but it's a string derived from the properties of the model. If I delete, for example, this curriculum there, we can see here that the model updates also because the type has disappeared. And I can, of course, undo all of these actions and restore the previous state when I press these standard undo and redo buttons. For the activity editor, the nice things that the students could provide is, for example, some kind of compartment and nesting of compartments themselves. We can see here also that we have some different representations. We can have dashed lines and all the elements that we like to have, and we have specific representations, for example, for the received events. One of the cool things that the students could provide here is a nice link representation. The exceptions on loss in UML are represented as lightning bolts, and as you can see, you have a nice representation here for the links, which we could not do initially with Papyrus because the framework could allow you only to draw basic edges. So as you can see here, we can just create these lightning behaviors. Another cool stuff to see here is if I create a new call event. In the environment, we can see here that there is some red flag because there is a live validation which is plugged in. And if I edit the elements there, I can just provide some behavior to call. In this case, I only have this activity to provide. So the red flag that says that there were no behavior associated now says that it's only a warning. This warning comes from the fact that there is no control flow coming to or outgoing from this order there. And let's jump finally to the final demo for this one. This is the use case diagram. As we can see here, we also have some nice representations for the actors, which is SVG based. And one of the nice things also that we can have here is the the complex creation of elements. For example, there, when I create some new extensions there, we can see that we have some baggage extension point that has been created at the same time that there was this extension provided in the group check-in use case. So yeah, let's back to the feedback from the students. As we can see, all groups could produce a very decent initial state of the diagram editors for 5 of groups. That was a fine implementation. All the students has as a feedback that the learning curve, of course, was a steep one because there are a lot of technologies involved here. As you can see here, we have EMF APIs, UML meta model to learn, model server, and GLSP Sproti implementation to understand. And there are mixed language because all the server part is based on Java, and the client side is mostly on TypeScript language. But the nice thing is we, thanks to this separation and the nice patterns that we have implemented, there is a nice and clean architecture with a clear separation of the concerns, how to handle the edition of the model, how to display the elements, and all these things are very nice separated. Some missing features were reported. The compartments, default compartment could have a better support. There were some missing things like the multi-line support for the comments nodes. For the complex edge and node creation reorient, some of the client side selection, if it's possible or not to create the link or to reorient it, the client side could not decide by itself. It was not sufficient to work on element types on the client side, but the server should be able to handle that. And finally, there was some things missing like anchoring to lines, so it's not possible yet to do some comments links onto the, for example, associations. Most of these missing features were addressed since this experiment that was conducted earlier this year during the summer mostly. So in GLSP 1.0 that is coming out currently, you can find some of these improvements there. For the Papyrus project, it was only a diagram part on your study, and there are a lot of investigations still to perform, for example, for all the table-based and the form-based editors. Even for the form-based, that's been already partially done also for the cooperative use. But this nice set of technologies allows an incremental transition. That means that many customization frameworks and many of the existing frameworks from Papyrus could be reused. Initially on the server side, for example, the profile extensions, element type frameworks, which is a heavy part of customization within Papyrus, and the architecture definition also could be reused on the model server. And thanks to these technologies, there could be also some improved architecture within the tool with different services being clearly split, and also benefits from the dependency injection to provide some more customization at runtime, and the users could just easily customize the elements. So that's it for the feedback, and thank you for attending this session. I will leave now 5 minutes for the questions, and please feel free to evaluate the session, and please leave a +1 for us. Thank you very much. Thank you. We'll now switch to the Q&A part of this presentation. Just browsing there the questions. The first one I see is, what do you think is most crucial for the base technologies of UML tools in the future? The good thing there with GLSP is that we can reuse a lot of existing UML implementation and existing models and profiles thanks to the UML model server implementation. The UML tools are very often used as a platform and are customized for specific methodologies and specific domains. Then the customizability and the control over the rendering. That means, for example, having direct access to CSS or SVG is key there for DSLs. That's something that we have developed in the past with Papyrus on GMF, on top of GMF, but that was quite hard work. And thanks to this adoption of directly SVG and the CSS, it's very easy to access to the figures and modify their rendering here. What is nice also is the integrability with the tool platforms like VSCode or Theia, as we have seen there. And we could also imagine to plug to plain web applications like PLMs or Bugzilla, Jira tools, these kind of tools. And so we could simplify the access to the users, to the end users, to the models, to the domain experts. For example, I don't know, for reviewing diagram, that would be much easier using this kind of tools than just having a plain desktop tool to install and then to launch and to investigate what is the current model status is. Just on the next questions, Papyrus also makes heavy use of the tables. What framework or solution would you investigate for table support? Currently, we have very good experiences with React table on the UI side. It's scales pretty good and it's pretty usable. There are a lot of features already available in this component, and then we would need to come up, as for the diagram, with a protocol for transferring the data and to develop the backend also. Next question is the focus only UML, and what about CSML and CSML v2? Currently, the experiment with the students was about UML, of course, but all the client side is pretty generic. So that means that implementing a new language would be just reusing or just having a new extension to the GLSP to support the CSML and CSML v2 languages. And for example, for CSML, it would be already possible to reuse a lot of things that have been implemented on the CSML edition part on Papyrus, and then only provide some additional rendering or some additional diagrams on top of it and display them in the tool. Next question. As far as I understand, the main functionality in Papyrus would be retained, such as element type, architecture, framework, etc. That's typically the goal of such technology stack. That means that everything that goes on the edition and all of the model management would be transferred to the server side, and we could reuse part of them. The goal would be to isolate them in some modules that would be reused later or could be replaced when we deploy the application. If we want to have some changes in these frameworks, for example, for the element types, definitely that should be only server side elements, and they should be manipulated there. And so we could keep them until we find something better to implement these elements. That's the nice advantage of this stack. There is that we can keep a lot of things that have been already developed for Papyrus, and there all of these tools that have been customized around Papyrus. Next question: is there somewhere to download from this tool? Currently, no. The experiment was only shared with us, but I think that you can already have a look to what has been done with the Coffee editor or the eCore editor, which is located into the EMF Cloud repo, and there is the code is open source there, of course, as it's an Eclipse project, and you could have all the things there. Next question, and I think that will be the last one. Do you provide the collaboration feature? Currently, we don't provide such things as dynamic collaboration, but we have some experiments to work with EMF Compare or to have an integration of EMF Compare so that you could have a Git integration and work on the Git model. There is currently no real-time collaboration plans or already implemented. I think that's almost all. There are a few questions left, but I think we won't have time to browse them all. I want to thank you all to come there. So thank you for attending, and please vote for the session, and see you soon in our next talk. Thank you.